Okay, here we go. You have a few more derivatives to learn. Over the course of these next few days, you're going to learn all those derivatives. The derivative of e to the x. And this is the best derivative of all. It's absolutely incredible that the derivative of e to the x is e to the x.
What? And we're figuring out y today? Or do we already? I just heard a b.
Could you rephrase your question, Emma? I didn't quite understand.
Are you figuring out why e to the x?
Is this what our unit
lesson thingy is on?
Yeah.
So we get to finally figure out why it's the best.
I would love to show you why it is. It would take us about a full day. We just really can't move through it. But if you want to look up the proof for the derivative of e to the x equal to e to the x, it is pretty neat. We would say it's more of a kind of a calculus 2 type topic to investigate that. It's pretty neat, but yeah, we just don't have time. So, okay, all right. Another one for you is the derivative. And this is where people make mistakes, but the derivative of, say, b to the x. So if the base is not e, then the derivative is b to the x, just like the derivative of e to the x is e to the x, but then you got to multiply it by the natural log of b. All right. All right, so let's try a few problems using those two pieces. We just want to do a few problems today and get you set to your homework. F of x equals x cubed times e to the x. How will you go about finding this derivative? Good, so f prime of x is equal to? Okay, let's start with the 3x squared times e to the x plus times x cubed. And it's most common on the AP exam that you'll see this written in factored form. So if you factor out a what? And an x squared, so x squared e to the x, you are left with 3 plus x. And that's your derivative.
Oh.
What's different about this one?
The x is up there.
Yeah. Anybody want to guess what we have to do here?
You do the
We're going to say it's e to the u. We're going to say that the exponents of an x, we're going to say it's e to the u. So what would u be? 4x squared. What's the derivative of 4x squared? 8x. And the derivative of e to the u is e to the u. So when you multiply these, we get f prime of x is equal to 8x e to the 4x squared. What's dumb about it? Like, I just gave you the best derivative in the world. The derivative of e to the x is e to the x. Like, literally every single kid in the school is capable of finding that derivative.
No. The 4x squared is still in a powered form. I think that's coming down.
Yeah, me too. Like how the powers to a power.
Power to a power, you don't like that?
No.
Okay, all right. Well, everybody's entitled to their own opinion. Some people like modern country music. I mean,
Somebody like Zach Bryan.
yeah, it's like.
You literally like that.
Literally, when I ever listen to him, it's on it.
I'm a little offended now.
All right, what rule do you use here? The quotient rule. And the derivative of the top times 2 minus x minus the derivative of the bottom, which is -1. And so AJ says plus e to the x over 2 minus x quantity squared.
Why does he go by AJ?
What's
your middle name?
John.
Really?
No.
We know this. Jacob.
Yeah.
That's right, Jacob means deceiver. That's right. We talked about this. Yeah, deceiver, liar. Okay, so we're going to factor out an e to the x. What are you left with in the top? 2 minus x plus 1 over 2 minus x quantity squared. So if on the test I said to write it in factored form, I would be expecting this to look like e to the x times 3 minus x over 2 minus x quantity squared.
Wait, what? Combine.
Two just combine like terms of the top.
2 and 1 makes 3. If I could just move on a little bit further to this, does everybody see that you could factor out a negative 1 out of the 2 minus x if you want to? What happens if you square a negative 1? Get positive 1. So this is actually the same as I would never expect you to do this. I just want you to understand this could be written differently. It could also be, hey, come on. This could also be written as e to the x times 3 minus x over x minus 2 quantity squared. Because if you factor negative 1 out and square it, it becomes positive 1. Those are the same expressions. Trust me, if you square that out, you get the same as that squared. Okay?
Yep.
And obviously you could factor negative 1 out of that piece as well, couldn't you?
Yeah.
Okay, so now that you see that. All right, let's look at one that's a little bit more challenging. I will give you a hint by telling you we set up a chain rule here. Maybe want to guess what the outside portion is.
Order the U.
Order the u. And the inside would be, what is the derivative of tangent of x? Secant squared. If you still don't know that, you need to figure that out because you're going to use that the rest of the year. What is the derivative of e to the u? What is the derivative of e to the u?
E to the U.
E to the u. What's the derivative of 4 to the u?
4 u.
Natural.
Times the natural log of 4. So you can see we get f prime of x is equal to 4 to the tangent of x times natural log of 4 times secant squared of x. We're okay with that? Okay, try 3 more. Ooh, that looks tricky. What do you want to do there, Rhea?
You should move the 3 and sign outside
Yeah.
for the power.
Reduce product.
Aren't you gonna have to do chain?
Okay. Okay, Rhea does this correctly, that you can write it as sine of the root of x to the 3rd power. So obviously I'm going to set the chain rule, right? So we e to the u. Then we have 3 sine of the root of x cubed. I know the derivative of e to the u, it's e to the u. But how would I find the derivative of 3 sine of the root of x cubed? Oh, and it's not 3 being cubed, is it?
No, it's just the sign.
Chain rule again. So I would have 3u cubed. And then what? Sine of the root of x. Be 9u squared. How do I find the derivative of sine of the root of x? Another chain rule. So I have sine of u, I have the root of x, derivative of the root of x. Yeah, 1 over 2 roots of x. And the derivative of sine of u is cosine of u. So I guess when I multiply those together, you're going to have a top, which is going to be cosine of the root of x. And then the bottom will be 2 roots of x. So then the derivative that's going to go here is this guy. I will have 9 sine squared of the root of x times cosine of the root of x all over 2 roots of x.
How did you get the top part of,
This guy right there.
like the sine squared?
So I have to take this and plug it in for u.
Yeah.
So I'm going to be squaring the sine of the root of x. And now I've got to multiply all that together. So it looks like in the denominator, I get 2 roots of x. In the numerator, I get 9e to the 3 sine cubed of the root of x times sine squared of the root of x times cosine of the root of x. That's a tough derivative. Well, when you think about it, chain rule 3 times. We're pretty good at the chain rule now, aren't we? Could be a lot worse. Try the next one on your own. Okay, you can glance up. The way that you set this up is you have u to the 1/2, and then the inside part is 4 minus e to the 4x. You know that the derivative of u to the 1/2 is 1 over 2 roots of u. When you take this derivative, what's the derivative of 4? Yeah, it's 0, right? So in order to find the derivative of negative e to the 4x is just, again, negative e to the u, and this is a 4x, the derivative of 4 is 4, or derivative of 4x is 4, and you get negative e to the u. So the derivative is negative 4e to the 4x. Which brings up an interesting point that hopefully you guys can catch on and make quick use of. But if you have e to the 5x, the derivative is just simply the derivative of this, which is 5 times e to the 5x. So if you have e to the 10x to the 4th, then the derivative of 10x to the 4th is 40x to the 3rd times e to the 10x to the 4th. So when you're doing a simple chain rule problem like that, it just always works out to the derivative of the top, or the derivative of the exponent moved out front. So if you have e to the secant of x, then the derivative, what's the derivative of secant? Secant of x times the tangent of x times e to the secant of x. So it just ends up being the derivative of the exponent times the function. So that makes working with e really nice. So if you remember in pre-calc, a lot of times people are going, e, what is e? And it's like, why are we even doing it? And I find e confusing. Well, you can see in calculus, e makes things pretty nice, doesn't it? Yeah, so we like it. So let's work this through. We've set it up. As I multiply, I get the negative 4e to the 4x. When you multiply these, notice it's going to be a negative 2 in the top. It's going to be an e to the 4x. in the denominator, we have the square root of 4 minus e to the 4x. That's your derivative. And so one more problem. You guys can have some time to work. A little bit more time in these next few lessons because we're just covering small pieces. Secant of EA pi x. A is simply a constant, so it could be like the number 2 or 5 or anything like that. We're given that indication because it's f of x, so we know x is our variable. Notice in this problem there's just a lot of letters, right? I mean, you might say there's no numbers. Well, there are numbers. I mean, for example, e is a number and pi is a number, but they don't really look like numbers. So if we're going to set this up, it's just a very simple chain rule setting where we say secant of u. And then what we have for u is we have e to the a pi x. And what is the derivative of secant? We've just talked about that. Secant of u times tangent of u. And then we just talked about, in order to find e to the a pi x, that derivative, all we have to do is just take the derivative of the exponent and push that out front. What's the derivative of a pi x? A pi. So this derivative is a pi times e to the a pi x. And so we'll just multiply these pieces together. And so the derivative is equal to a pi e to the a pi x times secant of e to the a pi x times tangent of e to the a pi x. That's kind of fun to just look at that. It's like neat, you know, right? Wasn't that bad. Looks interesting. See, when I see it, I like right away. Why are you calling me?
At this time, we are entering into a hold. You may continue teaching, but teaching staff please lock your doors. All students report to the nearest classroom.
Mortified, I guess.
Why are your eye twitching?
So I'll just say for me, what I'm wondering is, I wonder what it looks like. Every time I see a function, like I wonder what it looks like if we graph it.
Are you gonna show us what it looks like?
Well, I'm going to look at it on my own. I'm going to set you guys to do your work right now. If you open up your homework, I think everything should be kind of good to go for you. Miss Rhea has her higher derivatives done. Just needs to focus on her word problems then, right?
Is there an answer to your question? Why do we need a word problem?
I've looked for one. I can't find it. The first one is posted, but the one with the word problems, I need to find it yet. Hopefully that'll be today before the end of the day.
I found it the other day.
You did it?
It's up there.
No, it was up there.
Oh, was
It's
it?
not online, but it's up
Oh, it's not online, but it's up here. Okay.
Whoa.
I was like, I just.
Oh yeah, here it is. Yep, there we go.
Do you mind if I take a photo?
Yeah, you go ahead.
Illegal.
Back here.
Yeah.